this computer, I guess. No, I'll show slides with a lot of like screenshots and things, but I wasn't planning anything live. That being said, you can connect to the cluster from anything. So
It's on your own. Oh, no.
no, I do it with my phone a lot just to check if things are running. So for any device, really, you can do it.
You don't have to be on VH1.
No. Yeah, I do it.
To VH1, so.
I do it like on my phone, like at the grocery store, not on Wi-Fi. Like,
Oh, okay.
yeah, like anywhere. Just to check if my code's still running. Yeah, I get nervous.
So did I leave the stove on?
Yeah, yeah. All right. I guess we can go ahead and get started while coffee grabs coffee. And the recording is going, just so everyone knows. So this presentation is going to focus on like how you can get started using R and Python on the Duke computer cluster. Let's make my slides now again. I'll go over R first and then Python. They're very similar though, so we'll probably go through the R part kind of slowly and then the Python part a little more quickly because it's the same basic idea. So I'll first talk about kind of how you get access to the computer cluster and use it. We had some sessions in the previous semester about kind of from the computer cluster and OIT folks that talked about kind of what the cluster is. But just to kind of briefly recap that, the Duke computer cluster is what's called a high performance computing cluster, or HPC. You might see that term a lot if you try to Google things related to this. And that means that your computer is, getting that computer to run things. So Duke has a lot of computers that we can use as students or staff. And so it kind of seems like you're running code from your computer, but it's actually happening somewhere else. And that lets you use a lot of like resources that you wouldn't have on your computer. Um, Kind of similarly, it really doesn't matter what device you're using. So if you use your laptop, your phone, like a really old laptop, as long as you can connect to the internet, Chromebook, like anything can do this. Um, We'll talk about how you can make a custom R package library for the DCC, how you can run basic R code on the DCC, and then the interactive version of RStudio through the service that Duke has called On Demand. This will make it really look like you're running code on your own computer. It's very similar to the desktop version of RStudio that people have maybe used before. And then we'll run through basically the same things with Python package management, Python code, and then there's also an on-demand version for Jupyter Notebooks, which is one of the main Python environments. And also feel free to stop me if you have questions. So I put some helpful links here at the beginning. First is the actual pages from OIT about the DCC. And then they also have a particular training page. So they have a lot of information about how to use the DCC and how to get connected. They're also very responsive to emails. So if you have any issues or there's something you think you can use the DCC for, but you can't really figure out how to do it, they'll do it for you. Some of the things you can do on the DCC, they will have to like set up for you. So feel free to reach out to them. They've been super helpful when I've interacted with them. I also won't cover these really at all today, but I put two books for getting started with either R or Python that are freely available online. R for Data Science is the foundational book about how to use R for analyzing any sort of data. And then there's a similar book for Python called Python Data Science Handbook. And those links both go to the free versions of those books. So first, getting access to the DCC. Basically, this is kind of the workflow here on my screen. Faculty, they cover this a little bit at the DCC session we had last semester, but DCC ownership basically goes either to faculty members or for some reason to graduate students. And those are like the two entities that can have sort of an account on the DCC. So if you're a graduate student, this link here on the bottom that says claim through research toolkits, you can actually get your own part of the DCC independent of being like, even if you haven't joined a lab, even if you were like your first day as a student, you could get your own um, a part of the DCC, and I encourage everyone to get that. It's very helpful to have more space. Faculty members get 1 terabyte of storage space and they get like a project, and then they can add anyone else to their project. So graduate students can be added to that, postdocs and staff, that's like the primary way that you would be connected. If you never have used the DCC before or no one in your lab has, you'll have to contact them to set that up. But most of the time, if someone is in your lab, is like an administrator on that, maybe your faculty member, or maybe you're a more senior person in the lab, they can give you access like using as an administrator. So I'll show this is what the Erigu Labs page looks like. You can see that the actual person is assigned to as the PI is Charles Eriglu. I don't know if Charles has ever actually looked at this page, but the administrators are Dr. Christy Sakers in our lab, or Hayes is her married name, and myself. And we can add other lab members to be able to access it. So those are the kind of the people that you would go to. This is the Research Toolkit's website where you just manage access to your partitions and things like that. Um, but again, if you need any help with how to do that, you'll need to talk to the DCC folks to set that up. But it's pretty easy.
As an ad.
Other admins can add admins, yeah. Yeah. Or at least I'm fairly sure, because I'm pretty sure Christy added me as an admin. Um, but maybe you have to email the DCC to do that. I'm not totally sure about
I
that.
mean, I guess where's Charlotte with?
Paula should be able to for sure, yeah. And yeah, just do it with them. Yeah. Right. And when you, yeah. Yes. So Caleb here on the bottom, our most recently added person is my undergrad. So yes, you can add undergrads, anyone with a net ID, and you log in through your net ID.
Could I add them? Or is that like? I mean,
I think you probably could. I haven't tried. 500 gigabytes.
Oh, wow.
Yeah,
Okay.
and the PIs only get 1 terabyte, so it's quite good. Yeah, the page looks about the same, so probably you have the same permissions and everything, I would think, but I haven't tried that personally. That was actually my next slide is the doctor allocation here. So the project looks kind of the same, so I think probably you could also add people to it, but I haven't actually tried that. But yeah, it's 500 gigabytes and it goes in this folder. I guess I should show there. Your group is HPC group Erigu Lab or like whatever your lab group's name on there is. And then if you have the doctoral partition, it's HPC DCTRL for doctoral, and then your net ID. Yeah, so that's like the actual storage, like where you would save files and things. But to actually connect to the DCC on Windows, I use this software called Putty. There's a lot of different versions, but basically you want something that does SSH connections. On a Mac or a Linux, the terminal that you already have can do that by itself. So for that, you just need to run this code SSH your net ID at dcclogin.oit.duke.edu. Um, I apologize that I took screenshots of the Mac in our lab because I didn't want to bring a flash drive over there. But you would just run that, and then in either case, I'll show the Windows version where you can read it a little better, but you'll be asked to put in your password. This is your regular like Duke NetID password. And then you'll be asked passcode option. I wish they would take that away because there's only one option now, but you have to use the Duo thing to like do multi-factor authentication. But after you do that, this goes from like being in parentheses with the idea of that login to actually just showing where you are on the DCC and turn screen. So that means you're actually like logged in. Here is the putty version for Windows where you'll have the same like password request and then the login thing. And then it gives you the same sort of thing where in green it says where you are on the cluster. It'll also print how much storage you have at all the places that you're allowed to store things. So you can see everyone gets a home folder just for having a net ID. So that is there. and there's a pretty small amount of stuff, 25 gigabytes. So that's mainly for like configuration files and things like that. You don't want to put too much there. Um, the group folder, because I'm part of Eric Lab's group, has 1 terabyte, like I said, the doctoral position, 500 gigabytes. And then everyone has this folder that's work slash your net ID. This I guess it has a cap for my personal part, but this is a really, really big space. You can do basically anything there, but it is periodically deleted. So you just want to do things that are relatively short term. I think they do like 70 days or something like that. But I've seen it, if it gets full, they delete it more frequently. So just don't leave things for more than a couple of days on there. But if you need to load data and like run a lot of computations and you're only going to save like pretty small output files, that is a good place to do that. Um, so we're on this little partition that says login here at the bottom, um, but you want to get off of that because that's where everyone that logs into the cluster logs in. Leslie or Kavya, could you make the lights dimmer? I feel like it's kind of hard to see this. It's right behind you. Yeah. You know, is that better? Okay, cool. So you want to just run this code srun space dash dash pty space bash dash I. And this is just telling the manager for jobs on the cluster is called Slurm, like SLURM. So srun is the simplest way to use that. And you want an interactive bash session. So this basically just means I want to run code in an interactive session and I want like a different computer. So this takes you off of this login computer and onto this computer that just says core. So that means that now you're not on that login computer. So if you try to run computations from the login computer, one, it doesn't have very much resources, and two, you're going to slow down everyone else trying to log in. So it just kind of like makes it harder for everyone else to use this. So getting onto this interactive node is the first thing you should do. And yeah, I just memorize that over time. The slides will be on the website, like the QLS website, of course. And these I actually typed. So if you want to like copy paste, I have most of the commands up above the screenshot. So then navigating to like a folder that I want to work in, use the command cd. And these are all like Linux bash commands. So if you want to look up like what are the main commands to use, DCC's website also has some instructions on like the basic ones. But this just means change directory, so it's just moving us to a different folder. It's a little faint, but here in blue is where it shows you what folder you're in. So right now it just has a tilde. That's your home directory, this HPC home JS664, but it will just show a tilde because that's like your home for your person. But when you change to the work, it now says slash work slash JS664 to show you that that's the folder that you're currently like residing in. To see, I guess one of the main reasons to use the DCC is that there's a lot of software already installed on it. So if you use this command module avail, it shows you which like modules are available. This is not nearly all of them. You have to kind of like scroll to even see all of them. But there's just a ton of things already installed there. If you need something installed that isn't there, that's also a time where you can email the DCC and they're pretty good about like installing things if it's something that like a lot of people would potentially want to use. If it's something very personal to yourself, I would install that on your lab or your doctoral partition. But if it's a tool that like a lot of people probably would want to use, then you can email them about it. Um, so if we want to use a particular module, you can use this module load command. And so then that makes it so that your session now like has that tool installed. But you don't really have like it's just kind of opening that door. You don't have to actually go through the installation process like you would if you were using your own computer. And you can either usually call the name of it or the name with the version number. So if we look at the module avail, you see that they all have like the name and then most of them have a forward slash and then like a version number. If you just put the name, it will usually just give you the newest one that's installed. But if you put the full version number, that also will work. So you can see that for like a lot of them, um, like we'll talk about later, Anaconda. There's like several of them here, but if you just say Anaconda 3, you'll just get that newest one. So like I mentioned, the times to use the modules, pretty much most software tools that you're going to use that are like Linux installed, it's just a lot easier than having to install them yourself. We also have, limited storage on the DCC, so wasting that on some package that's already in the modules is not very useful. Um, it's not recommended for tools that are like very specific to you. Those probably aren't going to be on there. Or if they need a lot of customization. So you don't have those tools are all saved on the DCC in a folder that you don't have permission to like open. So you can use the tools, but some tools are designed so that they like change things in their own installation directory, and that won't work for the modules that are installed. So for some tools like that, you might have to install your own version. Um, R and Python are sort of like that, but there are workarounds for getting those to work. Yeah, like I said, you don't have write permission for that. So if it really requires that, you can, but we'll kind of overcome this limitation for R and Python. And for other tools, sometimes you can also do this workaround. Um, I guess I'll stop there before we start talking about R. Is there any questions about that initial connection part? Something straightforward. Um, I guess the thing that I should mention that I'm not entirely sure on, the DCC used to like require you to take their training before you used it. It doesn't say anything about that on their website anymore, and it doesn't seem like they're offering the training very often anymore. So I don't think they're doing that now. And they like have on their website to just contact your lab member that's your person of contact. Um, they do still have trainings online and they do occasionally do them in person as well. So definitely feel free to do those, but they're basically what I just covered. So it's not like a lot more than that. I guess the other thing that I should warn, you can delete stuff. So be really careful when you try to delete things. I won't talk about that right now because you probably don't need to delete anything to get to this part. But if you're using commands like remove, which is RM, definitely check where are you like, are you deleting the thing you think you're deleting? It's a little bit easier in the command line to accidentally delete something than it would be like on a regular computer that people are more comfortable with. So I guess with DCC use comes like great responsibility. Um, that being said, you probably don't have permission to delete things from other people, so it's probably you'd only delete your own stuff or your lab stuff because you probably have like permission for your lab stuff. Um, anyway, for R, if you used R on your regular computer, it would kind of automatically install packages to where you installed R. And you're not allowed to do that on the DCC if you're loading the R module. So what we can do is make a separate package library, which is basically just a folder in one of your spaces that we want to install packages to, and then still get the module version of R to look there for the packages you installed. So you want to put that in a folder that won't be deleted, like group or doctoral, where you have enough space. And I think that's probably the primary things you should be keeping on group and doctoral. I would keep data on the work directory and then on like actual physical computers in your lab space. I don't think even the doctoral or the lab directories are good for storage of data for any like significant period of time, just because they fill up quite quickly. Um, so I'll use work as an example or for some of this stuff, but if you use work, it will like you'll be able to get things installed, but you'll probably have to set it up again the next time you need to use the cluster. So just be mindful of that. That's what I used to do when our lab partition was really full. And just take really good notes so that you can set it up again if you need to. So to make a file, use this make dir, or make a folder rather, this make dir command, mkdir. I'm just going to call it rlib, and it's a little hard to see, but I'm at my doctoral partition. So this is a place that's not going to be deleted unless I delete it. You then want to go back to your home directory with cd tilde. And the reason we do this is because the configuration file is there. So if you use this command V, like VI, that lets you edit text files. And the text file here is .r profile. This probably is already written there, but it might get written the first time you use R on the cluster if it's not there. But this is just a hidden file. That's why it starts with a dot. So you won't usually see it if you check what's in that folder. But it looks something like this, where this is code that is like for your profile will run every time you launch R. So if there was something that you like regularly needed R to do, you can put it here and it will run every time you open R before you run anything else. So what I put here is some code that first gets the R version that's being ran using this like r.version command. It then gets this custom library path, and this is what you just made. So this is HPC doctoral JS664, and then rlib, that's that folder I made. You want to append the version of R to that because R actually will automatically make a folder for each version of R that you use. So if you switch to a different version, you can keep using this folder, but it will start installing new packages for the new version. And then this last thing is .lib paths, and it adds the custom path to the existing paths. So what this does is tells R, when you're looking for packages, the first place I want you to look is this folder that I made. So this makes it like the primary place that R is going to look for packages when you're using R. So even though we loaded that module from the cluster and it is in a place where there are some packages there, it's going to look for yours first. And then if it doesn't see the package in your folder, it will look in its own folder that you can't edit. So some standard packages are already on there, but if it's something that isn't on there, it'll look in your folder first. And oh, I copied that here so that if you want to follow along, you can copy this. Um, yeah, and yeah, you would just change your net ID or this path to wherever you want to put this folder. And so I didn't have it scroll down enough to where you could see R, but you can see there's a ton of versions of R already installed on the cluster. So I just copy and paste one. Some of these have this RHE18 appended to them. That's the folder where a lot of that modules are actually installed. So you might see that around. And once you say module load and pick that version, it will print that you loaded that module. To actually run R on the command line, you just use the command R, like just the uppercase letter R. And then it runs this stuff where it tells you what version of R that you're using. And it says that like where the R is. So you can see it's an opt apps RHE18R. And these are files that you can't mess with. It prints the version of R because R does that by default. And then this thing, which used to say, my core and like where I'm at and all of that and have a dollar sign, now it just has like a forward, like greater than sign. And that means that now you're like in R. So you can run R code here. So I just ran print. I'm using R now, and it gets the regular sort of thing. The main thing I would use this for is checking packages. So to like use a package in R, use the command library. So if we say library savage go or library gene overlap, right now it says error. There's no package called that because we haven't installed those packages. So this sort of command line interface I would use to check and make sure your packages are where they're supposed to be. And if they're not, you can install them. This is the example for gene overlap either with packages install, which is like the base version in R, or for things that are on Bioconductor, which are a lot of like biology related packages, you use this BioC manager install command and then the name of the package. And you can see once I run that in R, it starts doing all of this stuff and tells you like what it's doing. It asked me a question here where it said, warning, this folder where we want to install the package is not writable. Would you like to use a personal library instead? You want to say yes? Oh, I put this on the other slide. Maybe it's easier to read anyway. So then it says, would you like to create a personal library at this path? And what it's doing is this is that version of R that it read from the beginning. So you want to say yes to that. And then it's going to start actually installing to that directory. And you'll see stuff like this. This is the actual, like, a lot of the packages are installed from source, so it's going to have to compile them. So you'll see a lot of weird, like, computery looking stuff. You can kind of ignore it um, unless there's an error message. And then it will usually print out a bunch of other stuff. These are all the other packages it had to install that this package depends on. So if it's a very complicated, like, often like the bioconductor ones that kind of need a lot of things, it's going to do a lot of this here. But once all that installation is done, if there's no errors, which usually there won't be, you can say library gene overlap, and it should just not really print probably anything. And that means that it worked, like it found that package.
So you don't get an interface for any of this. So you can't run
No,
scripts.
you
Or
can't.
sorry,
We'll
you can't
get
edit scripts.
we'll get to that. I wouldn't edit. You can edit them in here, but I usually just run them from here. But you can.
This
Yeah.
would be like a make it on your own home.
Usually that's what I would
And
do
then
for a
drag it
script.
into the-
Yeah. You can edit them on here. You can't really write a script in the R thing. What you can do if you really wanted to write it on the cluster, say you were on like a Chromebook, you can use that VI command to write a file and just make it end in .r. And if you write R code, it'll run as R code once you run it. But that's like not a very good user interface. So this like interactive R, I would really only use to kind of check like simple things like a package or, make sure like a function is working, but you wouldn't like do anything that would take a while. Right. So here is similar, like I just want to check if this package was working. So if you go to Gene Overlap, website on Bioconductor, this is just the code that they have as an example of how to use it. So they have some data that is already part of the package. So I loaded that. And then Gene Overlap does a Fisher exact test between lists of genes. So it tells you if like in a certain like subset of a list, is a certain gene overrepresented more than you'd expect by chance. So they have just examples from the data set that they included of how to run that test. So, and it will print the results of the test. So I just ran those and you can see like it is printing things that match the expectation and it matches what's on that website as what the output should be. So that's, just a minimal way to let you know that the package is working. To quit using R and go back to using Linux, you just use this command quit with two parentheses. It'll then ask you, do you want to save the workspace image? I always say no. Doing this locally makes some sense because it helps you open R a little faster, but I wouldn't probably use that for the interactive like Linux thing. Um, yeah, so are there any questions on this? So getting to Rocky's question, if you want to use an R script, I would write this here as RStudio like on my computer, like physically, and that's where you can write the script you want to use. So it's just regular R code. This is the exact same example that I just did. So it's just library gene overlap. It loads this data that is already in that package. We make like a gene overlap object, and then it prints what's in the object, and then it runs the test like the actual statistical test on that object and prints the result. So if you want to run that, save it as something that ends in .r, like a regular R script, and then the code to run on the cluster, once you've moved that script to the cluster, is capital R script and then space and then the actual name of the script. And so now that I have that there, once you hit enter, it gives you the exact same output we had from the interactive session. So that's kind of the like clunky way that you can sort of use this if you want to use RStudio. Um, On demand lets you use this in a much easier way. So uh, the DCC has a page about using RStudio and on demand that's linked at the top. which has some instructions to get started that are similar to this. But if you go to this link, dccondemand01.oat.duke.edu, you'll get a page that looks like this. And there's four different pinned apps. There's more actually if you click. But this RStudio Apptainer is the one that we use for R. Jupyter Lab Apptainer is the one that I use for Jupyter. I don't actually know how it differs from the one beside it. And then DCC Desktop is actually kind of cool. I haven't played around with it too much, but if you click that, it gives you like a virtual Linux desktop. So then you could potentially use any graphical user interface software. So that is also an option for some things. But if we click on this RStudio one, if it advances, there we go. It gives you stuff like this. So there's a lot of options for like configuring it. The account should auto-populate to be you. It'll make you log in with your NetID to get here. You can tell it the wall time. So that's how long is it going to keep this session alive. So it will turn off after a certain amount of time. There's definitely a limit. I don't know if it actually says on here. I think it's in those other pages. You can ask for how much resources you want. So how many CPU cores you want to use, how much memory you want to use. I have it at 208 because I believe that is the maximum. If you want to use a graphical processor, I like to put my email address. So if you do that, it'll email you when your session is ready or when it's finished. Um, and I don't usually add other things, but there's some things where like if you needed some special parameters run, you can do them there. But if you have all that done, you can just click this launch button at the bottom and you'll first get this page, which just says, be patient, your job is in the queue. So depending on how much resources you ask, this could take like a minute or two. I've never had it take even much longer than that. So even if you ask for a lot of resources, it doesn't take too long. And then it should switch to saying this once it's ready. So this gives you how much time do you have left? So 3 hours and 59 minutes. And then if you click this here, it says connect to RStudio server. And once you do this, this is what the page looks like. So it looks basically identical to using RStudio on your personal computer. Um, so what I usually do first, it's maybe a little too small here, is I copy and paste that code that we had in our R profile. Unfortunately, when you launch RStudio on demand, it will not run that R profile code for some reason. So if you just put this at the beginning of the scripts that you have in there, it will still look in your personal package directory. But you have to kind of have it at the beginning, which is slightly annoying for using this, but I mean, it won't take long to run that. So just remember to include that. And that's on the previous slides. If you want to copy it, it's exactly the same as before. And then you can, load packages and run code like you normally would. The file system here is your home directory, but you can move it if you need to. Like you can I would write files, somewhere else, like on your work directory or something. You'll have access to all of your regular DCC cluster folders from here. And you can see them in more of a like intuitive way with our Studio file system. And you can do, anything that you would normally do. You can write scripts up here. You can run the console. You can view objects, like all the stuff you do in the normal RStudio interface. So it's quite nice for that. Um, so I think for any sort of medium intensity or like developing code, the RStudio interface is really good. If you do have R code that's like super high resources and things like that, I would run it as like an R script from the command line. But that is kind of a rare case, I would say. R can't actually really handle that much. That's very computationally difficult. So that's probably like more of a special case.
Just if the output of your script or whatever you're running is, let's say a plot.
Mhm.
If you're running command line, it wouldn't generate that plot, correct? It
So
wouldn't be populated.
if you write it to a file, you
Right, if
can,
you wrote to a file,
yeah,
sure,
but it won't
never
show
goes to
anything.
the
No. With the on-demand, it will. So
Right.
it will show up in the notebook just like it would if you were using it on our studio. So if you do like an R Markdown file, it will show up like the plots as you do it. But yeah, if your code only generates a plot, you won't be able to see it if you're using the command line version unless you write it to a file. And then if you write it to a file, you'll need to download it from the cluster and then
Right.
open it on your computer.
There's no
So it's
fit check and meets.
not really, no.
Okay. Should be pretty sure.
Yeah. Yeah. So let's say like if you're testing something, try it on here and like a subset of your data and like make sure it's working. And then if it's going to take a whole day to run, then you can run it as an R script. Any questions on that part? This is the end of the R part. All right. So Python is quite similar. So Python has a bit of a better way to manage packages that are called environments. And the main way that you use this is through a software called Anaconda. Um, and it will manage packages. It's a little bit smarter than R in that Anaconda will actually keep track of which packages work together, like will actually run. So what you can sometimes have, especially for a lot of packages, like one version of one package that's needed for another, like they can get updated to where they don't work together anymore. So Anaconda actually keeps track of all of that. And so when you have an Anaconda environment, it will like downgrade or upgrade packages so that they will work together to the best of like its knowledge, which is usually pretty good. Um, it makes it really easy to have different versions of Python on your computer and access them very easily, which is, another one of the main problems. Like a lot of packages will only work with certain versions of Python. And these are very self-contained. So the Conda environment does a really good job of if you've made an environment, it's only going to look in that environment. It will not look anywhere else. So whereas in R, we were just adding that library to be like the beginning, like the first place to look. With Python, if you make this environment, it's only going to look in that environment. Um, every time I come back to this, it doesn't want to move. So like we showed earlier, if you go to module avail, Anaconda's already there, so you can load it. I missed one of them for some reason when I made my little box, but you can see it there on the side. There's a bunch of versions of it. You can run module load Anaconda. That'll be just the most recent one, or you can copy and paste a specific one. I guess one random thing to mention quickly, if you haven't used the terminal much, if you highlight something in the terminal, it copies it. So you don't need to do like Control C. If you do Control C, that actually like quits whatever is running. It's like it has a different use. So if you just like hover over it and click and drag, that'll copy it. And then right clicking is pasting. So if you copy something from like this PowerPoint and you want to use it, you copy it from PowerPoint like regularly, with like Control C or something. But then if you want to paste it into the terminal, you would right click. Yeah. Random thing maybe I should have put on the slides, but that's also covered in like some of the DCC resources as well. So here similarly, I'm going to my doctoral partition and making a directory called Conda environments or ENVs. Um, Conda is like how you call Anaconda from the command line, so I use those names kind of interchangeably. If you haven't noticed, everything in Python is snake themed. Um, So I'm making that directory and then going back to my home directory with cd tilde. And similar to the R profile, there's a file for your profile of Anaconda that's called .conda rc. So if you open that, it should look something like this. So the first line says auto activate base, and I have it as false. This means, do you want Anaconda to turn on every time you turn on the cluster? So if you do, you can. Base is when you install Anaconda, um, base is the like default environment. So I don't really use that one for much, but that's like what it starts out in. And then this is environment directories. It took me a while to figure out this way of doing it. So I've done it a few different ways of like managing packages. So I have a few different places where I've stored these before. But the one I made most recently is here at the top. And these are just like, it's kind of like a bulleted list. So it will look in that one kind of first. And then channels is here. It will change this if you need it like through code, but these are kind of the three most common channels for Conda, Conda Forge, BioConda, and then the default one. I probably would add these because a lot of the biology related packages are in BioConda or on Conda Forge. So once you've written that, to look like this. Um, with your own files, it won't let you read mine, unfortunately. You can then create an environment. Um, and it doesn't really matter where you are when you create this, it's going to put it in that file from the .conda ARC, like in that folder that we made. So to make a new Anaconda environment, you run conda create -in is what do you want to call this? So I just called it QLS test. And then I usually specify the version of Python. So I write Python equals 3.10. Um, you can also put other things here. So if there's like a specific package that you're doing this for, and like you really want everything to work for that package, you can write the name of that package and it will install it as it creates the environment. So that's kind of like when Anaconda really shines of like it will install that package and everything that that package needs, and it will do a really good job of making sure things don't interfere. So that's another option, but if you just want to make a new one, you can just tell it to install Python. Um, it's still going to install a bunch of really common packages by default. And it will ask you like, do you want to proceed? It will list them all. It's usually too long of a list to really see. So proceed, yes, no, and I just will type Y for yes. It will then like load for a minute. And then once it's done, it will print this where it says to activate this environment, use conda activate. To deactivate the environment, use conda deactivate. So one important note, like we made this environment, but we're still not actually using it. Like it does, when you make it, it doesn't by default turn it on. So to actually turn it on, we have to follow their advice and run conda activate QLS test. Um, and then it will actually show the full path to where that environment is. So HPC doctoral mynet ID, and then conda environments, and then QLS test here. And it'll be in front of which core we're on. So that lets you know that now I'm actually using that environment for Python. And it actually prints it here on the command line just because Python is so like critical to a lot of programs you would use on Linux.
Very interesting. So
Mhm.
this environment file is stored in the environment that folder that you just created.
Yes.
And how is it specified? Is that in the RC?
Yeah, so that's just when I put here, like, yes, it will by default do on the first one. You can, like in the conda create command, I probably have to look up what the flag is, but you can tell it for the precise directory to create the environment in, but by default, it's just going to be the first one listed. Yeah. I leave the other ones on because if you had made an environment earlier somewhere else, it will still be able to open it if it's later down in the list, but it won't create any new ones in those folders unless you like tell it to explicitly.
Just almost the WQ.
Oh, I didn't mention this. If you're using V, yeah, if you're using V as the editor to write it and like save it, you use :WQ. Um, yeah, I didn't mention that. Um, cool. So we activated that and it's on there. If you want to use Python, similar to R, you just write Python in all lowercase, and it will then tell you the version of Python. So this is another thing to check. Like, did it actually install the version of Python I asked for? So it's 3.10.19, which I just said 3.10, so that's fine. And then it goes from being, the $ thing to now it's 3 of the greater than signs. And that means that you're using this, interactive version of Python. I use this the same as I do with R, where you can just try to like import a package. So one of the most common Python packages is called NumPy. In Python, you can tell it like a nickname basically. So I'm importing NumPy as NP. This is practically a requirement for most code to work. Um, so if I try to do that right now, since we just made the environment, it doesn't even have NumPy. Like it doesn't install very much by default. So it says module not found error. There's no module called NumPy. So then I'm going to exit. You can't really install packages very easily from Python. So exiting is the term exit with the parentheses, and now we're back in Linux. If I want to install NumPy, it's the most common way is pip install NumPy with spaces between each. When you run that, it gives you some code about how it's trying to install NumPy, and it will load for a minute. And then it should say successfully installed NumPy and give you the version number. So now if we go back into Python and try to run the import, it just doesn't really even print anything because it
So
worked.
this for each environment.
Yes.
Is there a way to kind of globally install for any environment that either exists or like
Um,
exists in the future that it would just automatically?
Not really. So the thing you can do if you have an environment you like and you want to make a new one that's very similar, you can kind of save the environment to a config file, and then in conda create you can give it that file and it will basically just make a copy.
So
So
just
it'll
copy
install
them.
everything that's in there already. So then you could like, if you want to like you have one working and you want to try something, but you don't want to mess up the ones already working, you can just kind of make a copy and then go from there. But there's no way yet to like install everywhere. Um, yeah. Um, So then if we want to leave again, we can do exit. If you want to run Python scripts that you've written, I didn't show an example of like writing a script. I actually didn't even write a file named this, but you would just write Python space and then the name of your script um, as a Python file, and that will run in the command line. Again, I didn't actually write a script, so there's nothing that shows up. Um, cool. Any questions on that part of using Python in the most simple version? Okay. So if you want to use on demand, there's this one extra step that you need. So for Jupyter notebooks to really work properly, you need to have this package called ipykernel, which is sort of just like under the hood how Jupyter Notebook communicates with Python. So you just want to make sure once you've made that conda environment, you do pip install ipykernel. It should work, it should say where it installed, make sure it's in that environment that you made. And then you have to run this code Python m ipykernel install user name. That should have the environment name, and then put a display name. And this can be whatever you want. What this is going to do is that it will make it so that when you run on demand, the conda environment will show up properly. And it will show up as whatever you put this name is. So you can pick whatever you want, if what's ever most helpful to you. But this should be the actual name that you made for the conda environment when you created it. So once you've done that, you can just go back to on demand, go to Jupyter Lab. The page looks basically the same as the R version. You can pick your account or whatever. Wall time is the same, CPU is the same, memory is the same. You probably would want more resources with Python than R in most cases, so it might take a little longer to run and all of that. But then you can just click launch, and it will, say that it's making it, and then it will let you connect to Jupyter. Similarly, once you launch this, it looks very similar to if you were using Jupyter on your personal computer. Um, it will um, have up here, did I zoom in? Yeah. So here in the top right corner, which I'll zoom in 1 second, it says Python 3 ipykernel as the kernel that it's using. This is basically equivalent to like being the conda environment that it's using. So that's just the default. If I zoom in, that's what it looks like. So if you click on this, it'll give you this pop-up where it lets you select the kernel. You want to switch it to the conda environment that you made, which should show up by whatever name you gave it in that code we ran earlier. So here where it says QLS test, I want to select this. And now it'll switch to saying QLS test up there. And now you can run Python code through Jupyter as you normally would, and it will have all the packages that you have in that environment. So if you need to install new packages, just go back to the command line version of the cluster. And you can run them with Jupyter like normal, with just like the play buttons here on the side and all of that. The file system, like with R, is the file system from the cluster, and all of that good stuff. Any inline figures that you make will show up in the notebook like normal. Yeah, and you have all that sort of interactive way. Similarly, if something's going to take, an overnight, this isn't very good. I only believe in that, let you ask for that much time. But if you want to be able to like interactively troubleshoot code, or if there's something that's very visual that you want to be able to see, that doesn't take too long, this is a good option for that. If it's going to be longer, write the like Python script and run it from the command line.
Wait, how long do you think the tax is for?
I don't know that I usually ask for,
160,
um,
but on R.
okay, I don't know. I usually only ask for 4 hours because it seems like a decent amount of time. I don't,
What's wrong? It actually was slower than.
To start,
I
or
don't even, I was taking like a spatial omics class and it was like humongous and I couldn't get it to work on any measurement, but.
is that for the Python or for the R?
I know.
Okay.
But I definitely requested like 24 hours, I think.
Okay. Yeah, I don't know what the limit is, but um,
I mean, I know that
Yeah.
if you ask for a week, you'll get a week. You can ask for like a stupid number of CPUs. Granted, this was, I think, over the summer,
okay.
so.
Yeah, maybe there is no
that's gonna happen.
strict limit, but yeah, I do think like if you're running something that's going to take a long time, if you run it from the command line, it probably will be
Yeah.
faster because there's just like all this overhead of using Jupyter Notebook and all of that. Yeah. I also didn't emphasize it here. It's covered a bit on the DCC. Um, I showed you how to run the commands for Python, or yeah, I don't have any slides on it. I showed how to run the commands for Python and R. Um, that's not using the Slurm manage like job manager. So if you look on the DCC website, they talk a bit about that. The main difference is that at least the way that I use it, there might be a more direct way. Whatever code you're using to run your Python script, I would write a bash script, which is the way that like Linux runs, that just runs that code or loads whatever modules that you need. Um, I guess I could maybe pull up a quick example in a second, but um, if you do that and you run the command sbatch, batch, that will use the actual Slurm job scheduler that the cluster has, and that is going to be the most efficient way to get code to run. So they cover that a bit, and I could show some more examples if people have questions on that specifically, but that would be more like I have a Python script that is going to run for a week or an overnight or needs a lot of resources. I think that's the best way for those sort of things. So this is my last slide, so I'll just summarize quickly and then we can do any more questions or maybe I can show some of the bash stuff. But for loading R or Anaconda, you can use them as DCC modules. The caveat is that you need some sort of personal library for the R packages or similarly like a Conda environment. There's also other solutions to these problems, but which is why there's so many different things on my version of the cluster that are similar to this, but I found this to be the easiest way to do it. You then need to tell our Python where to look for packages using that .r profile or the .conda.rc. And then you want to run our Python through either the command line, through scripts, or through on demand. Cool. Any other questions?
How do you say everything? So you were saying that you can't see them like into that.
Yeah, I should have probably covered this explicitly. So when you're writing your Python code, like if you're writing a file, you'll usually have a command that's like write CSV or something, and it will usually have the object, and then the next argument will be the file path. So you just want to put the same sort of file path in the cluster. So if you just put like myplot.png, it'll probably put it in your home directory, which you don't have a lot of space in. So you just want to write like /HPC group your lab / like your name or something, so that it's a folder that you have a bit more space on. The other thing that I should have shown, I use WinSCP to actually like access the files that are there. You can also use FileZilla or other what's called like a FTP. So what this does is that you have the same sort of login as you do for the cluster, which I'll do quickly. And this will on one side have your computer and on the other side have the cluster file system. So that you can just drag and drop files here. So this is how you would put scripts on and like take things off, which I should have explicitly put in the slides, but that's there. So I use Windows SC or I'm gonna say the name wrong. Windows SCP. FileZilla is I think what a lot of other people use. I know that's available on Mac and on Windows. I just use this one, so I like it. I think Globus also can do this, which I think is what the OIT recommended. They're all fairly similar. Um, the other thing, do I have a bash? Is trying to see if I have a bash script that would, I guess I can, let me just pull up one quickly. So just to show, I did such a terrible job at this. Just to kind of show what a bash script would look like. Pardon my really dirty computer. There we go. Um, so this is like an example of what those Python scripts would look like. Do I have the complete something? So you can just put like your Python code by itself, more or less, and edit that in whatever you want it to be. And then I don't think I have this shell file that actually runs with this, but the bash scripts are this .sh format, and they cover this on the DCC site if you want to see more. But basically, those all start with this comment that says like exclamation point /bin/bash. That says when you run this, this is bash script, which is kind of like Linux's operating, like what we were running in the cluster. You can then give it different arguments. These are basically the same as those arguments we were giving to the on-demand for how to set up the session. So like how many computer cores do you want? How much memory? Where do you want it to run? The email and all of that stuff. And then you can load whatever modules that you need. And here I'm running an actual, like, I'm just running code from this module called star, which does sequence alignment that we covered in the RNA-seq session a few weeks ago. But if you wanted to run your R or your Python script, you could just put that command that we had that was like Python and then the name of that script. And then to actually run this, I'll just type it here, but you would in your terminal, you would run sbatch and then the name of this script, which is like star, make a simpler name, but you would run this code star sbatch star dot shell. And then once you run that, it'll like queue that job. And then that job will run on its own, so it doesn't have to have any sort of interacting. And for that, there is like definitely no time limit. So it'll just keep running. You can ask for a lot of resources. I think
Does it tell you when it's done?
so if you put the email thing at the top, which I guess you guys probably can't see much with the
Oh,
glare,
I see.
it will email you when it starts and when it's done and if it crashes. So I have first here, I have sbatch dash mail, and then I have type all.
Found comment and add option or
Which thing?
what's on the right hand side of those percent signs? I can't see.
Oh, here?
Yeah.
Yeah, these are just actual comments.
So the comments are.
Yeah. Yeah. So if you put sbatch, it will actually like interpret it correctly. But if you have spaces after that, you can put regular comments as well. I had some comments just to say like, what does each of these things do? And so yeah, I usually put the email one first, and then I put type as all, so I get emails. It'll give you an email when it queues it, an email when it starts, and then an email when it ends. And it gives you an exit code, so it'll say basically, did it crash or did it actually finish running? Um, and then you can give the job a name, otherwise it just gives it a number. And then you can define where do you want to write the out file or the error file. So I usually do define that. Um, so it will save that to where you're running the script. And then how many CPU cores do you want? How much memory do you want? And then you don't really have to do this. I usually write where I want it to run. By default, it will run wherever you use this sbatch command, but better safe than sorry, I guess, to have it explicitly written out. Yeah. So that's the slightly more complicated way I would use it if it was something that was going to take like a while or a lot of resources, like sequence alignment, which usually takes at least a few hours.